Hello friends! In today's video from VrikshOnline, we are going to see how to effectively read a research paper. Reading a research paper is important if you are in the field because you need to know what others are doing and whether your work is already done. I know it may be difficult sometimes, so today I am going to give you a few tips to how to read it quickly. In our previous video, if you have not watched it, we discussed the types of research papers that are there in chemistry. And in today, we will look at in detail how to read it. So let's begin. So this paper talks about effect of regioisomerism on naphthalene liquids. So how does regioisomerism affect the photophysical properties of alkylated naphthalene liquids? Now let me tell you the outline of this paper. Usually all papers will have a few parts. First comes the abstract, then comes the introduction, then the results and discussion, and finally the conclusions. A paper must include references because you must cite all the papers that you have referred through in your work, and a paper must include acknowledgement where you say which funding agencies helped you. A paper must have figures and tables. So if needed, a paper can have those. If your paper can go without the figures, that's also fine. But the point is it should deliver complete scientific content. So let us see this paper. First, we see this abstract in the beginning. You can read through the abstract of any paper and first see whether it is of interest to you. So here we are talking about alkylated naphthalenes. If you're working in this field or if you're working in supramolecular self-assembly, this might be very useful to you. The introduction runs for 2 to 3 paragraphs here. Let me show you that. On the left-hand side of the corner of this particular journal, PCCP, you can see all the correspondence of the authors. So where are they from? You can find out from here. And then you see there are some figures here. So the figures can indicate what the work is about most of the time. So if I look at this figure, don't forget to read the caption. Sometimes students just see these figures and they make up something in their mind that this figure must be of this, but it is not so. So please read these information below the figure, the captions of the figure, so that you understand what it means. And then there might be tables like this included in the paper. You have table 1 here which shows all the properties of the liquid naphthalenes there. Those are synthesized. And then you have results and discussion. Now when reading the results and discussion, make sure that you understand what the author has done. Sometimes results and discussion can be very detailed and we might not require that much for our work. All that we might require is what the person has done and how he or she has proved it. Sometimes only that is relevant. So for that, you read the introduction, you see the abstract, what he or she has done, then scan through the results and discussion, see whether it interests you first, and then go to the conclusion and see what the person is trying to prove. Come back to the results and discussion to see what they have done again. So let's see, and then see the figures as well. Then some tables where these things are noted. So when a person is reading a paper in detail, you might need to go through each of these data very carefully. Otherwise, the abstract, the conclusions and the figures most probably give you a lot of information. You can see a lot of places we have referred all these things like table 2. So whichever tables and whichever figures are there in this particular paper has to be referred in the main text. So you can see figure S26 ESI. ESI means electronic supplementary information. So all the content cannot be put in the paper itself. So a lot of it goes in the supplementary information. You need to pay for the paper, but you need not pay for the electronic supplementary information. Because it is free of cost and accessible, there is no page limit. But in a journal paper, there is a space or page limit. So you can write only few informations there. And then there are some notes and references. So these references, so if you want to read similar papers, all these references might be useful. Say I want to, so how to read the references and which references to actually pay attention to. So say if I'm reading this paper, let me read through this. Functional pi conjugated chromophores 1-2. So if I'm a person working on functional pi conjugated chromophores and if I'm seeing a actual paper for that, then I will go to this 1,2 indicated in this particular introduction and I'll straight away go to that reference and see what that paper is about. So this reference reads a paper in science and a paper in chemistry materials. So I can directly go to that paper and download if I need for my work. So all these references will show which part is referred to through which paper. So the work, if it has been done before, it must be referred here. The supporting information or supplementary information consists lot of pages and lot of information. So first it has these, it will have the title of the paper, it will have all the authors, this is me, and it will have all the affiliations of the people, and then there'll be a table of contents. So it depends on the author and the publishing people how much you are going to write in the table of contents, how its design is going to be. This is a very systematic table of contents, so I'm showing you this. You have supplementary methods and then supplementary tables and supplementary figures. So each supplementary method, whatever we have done, we have put it up like materials and then synthesis and characterization. So all these details you cannot put in the paper. But say another person would like to synthesize the same molecule and present it in his work. So that person is allowed to do so. If a paper is published, you can make the same molecule and you can study it. So all the things should be very clear in my paper if I have made that molecule in the beginning. So let us have a look at how this supplementary matter is arranged. So first, materials. So what chemicals were used, what kind of purchase, from where, which company it was used, that also might be given sometimes. For example, here dichloromethane from Dojindo, N-hexane from Dojindo. So all this company names are also given, and what chemicals are used are also given. Say I made some crystals in the beginning. So which solvent did I use for that? Even those details I have given. So then comes synthesis and characterization. So if you are just interested in synthesizing this molecule, you need not read through the whole paper and results and discussion. You can just go to the supplementary information and see how the author has synthesized the particular molecule, because this is the relevant information you need. And characterization also will be provided in detail in the papers. So here all the molecules are there, and then how they are done, how it is done. So all this particular big paragraph is how it is synthesized, and then it is like how it is characterized. So it is characterized through NMR, C13 NMR and a mass spectrum. So all that details is there. So if you synthesize it again, your molecule should have exactly same spectrum. So you can see it's very nicely organized. Spectrum, proton, carbon and mass spectrum. So each molecule's spectrums are there this way. Let's go to the techniques part. Here we define all the instrumentation. Suppose a lab wants to buy some instrumentation for some kind of work, and such work has already been done before. You can refer the supplementary information and buy a similar instrument. Then comes supplementary tables. Now these tables we could not put in the main text because the place was less, but this information is required to prove. This information would have been referred in the main text. So all the details has been put here in the supplementary information. So all the Cartesian coordinates, if you have taken a XRD data, all that is there. And then supplementary figures, more exhaustive ones which we could not highlight in the main text, all that is there. These are the optical microscopy images, polarized optical microscopy images, the DSC data. Soon I'll tell you how to do these research and how to analyze these data. So you must subscribe our channel for that. Supporting information may also have some references. If you have referred some particular paper for using some methods, you can refer it towards the end here. So this is how you need to read a paper. So I hope it is clear and you will be more effective in your research journey and in reading a paper. Stay tuned for our videos because we are going to bring a lot of research topics, a lot of things which are useful for masters, PhD and BSc students. This is for chemistry. So stay tuned to VrikshOnline. Don't forget to subscribe us there. Press the subscribe button. Do like our videos, share our videos and definitely do subscribe. Thank you.